previous years when you graph this, we would do an open circle to the left. All right, now when we're talking about interval notation with parentheses and brackets, instead of open circles, we're going to put a parentheses. And I'm going to draw this parentheses and close it because it's less than, and then shade it to the left. And that's the same concept as an open circle, but this time it's a parentheses to the left. Our interval notation, this is how we're going to write it. This is just the setup. We're going to have an ordered pair type answer, which is going to be our start value, comma, our stop value, with parentheses or brackets. For this one, I want all of these numbers, all the numbers to the left of 5. So that means my ending value is going to be 5. Right? And because this is a less than symbol, an open circle, a parentheses, I'm going to put a parentheses on 5, which tells me to get really, 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 really close to 5, but don't count it. Now, the other half is I want to keep going to the left forever and ever and ever. Not stopping. That means I want to go towards negative infinity. Because that's our value way over here to the left that never really even exists because it's just an idea. All right, our rule is going to be when we talk about infinities and negative infinities, we're always going to put a parentheses. Because it's not really a number, it's a concept. All right, it keeps going. So our interval notation is going to be parentheses, negative infinity, comma, 5, parentheses, which says I start at negative infinity way over to the left, which I can't count, and I'm going to stop at 5, but not count it because of the parentheses. So from negative infinity to 5, parentheses, parentheses. All right, the next one. X is greater than or equal to negative 3. Previous years. Closed circle to the right. Now, instead of a closed circle, I'm going to put a bracket opening to the right and my arrow going to the right. That would be my new graph. Now, my interval notation this time is going to say I want to start here at negative 3, and because it's a bracket, I want to count it. So I put a bracket, comma, and it keeps going to the right forever towards infinity, and we always put a parentheses. That's our interval notation. So starting and our stopping value, like an ordered pair with parentheses or brackets. All right, now we're going to solve graph and write as an interval. So I'm going to solve this. Get x is less than 3. Draw my graph, and since it's just less than, it's a closed parentheses to the left, which tells me I start way over here at negative infinity. I stop at 3. Parentheses always goes on infinity. Less than is a parentheses on 3. So every number up to 2.9999 repeating will make this inequality a true statement. All right, number 2. We're going to solve graph right as an interval. Subtract to 2. Divide by negative 5. And the special rule for this is when you multiply and divide both sides of an inequality by a negative number, you switch it. And I get negative 3. Less than or equal to is a bracket to the left, which tells me from negative infinity to negative 3, parentheses on infinity, bracket on the negative 3. All right, number 3 looks a little bit harder than it really is. This is a compound inequality. I'm going to solve it the way it is. So I need to get rid of this 2 and get rid of the 3. So what I'm going to do is I'm going to multiply the left, right, and the middle by 2. So those cancel. X plus 3 in the middle. 0 and 10 on the right. Now I'm going to subtract the 3. So negative 3 is less than or equal to x, which is less than 7. All right, my graph. Negative 3 and 7. And the way I'm going to look at this and the way I'm going to read this is I want to know what values of x will make this true. The values of x that will make this true are all of the values between negative 3 and 7. But since this is equal to negative 3 is a good value, And 7, since it's just less than, is not. So it's going to look like that. I want all between where negative 3 is good and 7 isn't. So I'm going to go from negative 3 to 7, bracket parentheses. That's my interval. This is my solving the inequalities in my graph. All right, last one, I have an absolute value inequality. To solve an absolute value inequality, I need to get the absolute value by itself. Next, I'm going to write two inequalities. 3x minus 4 is going to go into both of them. Leave it the same for the first one. Switch the inequality and the sign for the second. All right, so the big thing here is I have two inequalities. I need a word between them. My choices are an and or. What I want is the absolute value to be greater than 5. The way I taught this, the way I remember, is greater and less than. Right, so this is a greater than or equal to 5. This is an or statement. We also need to remember that for or statements, I want all the answers I can get, every number that works at least one. In an and statement, I want what they have in common. All right, so I'm going to solve both of these. I'm going to graph both of them. And since it's an or statement, I want all of it. So my or statement needs to include all of these numbers and all of those numbers. So I'm going to write this as two intervals. I'm going to go from negative infinity to negative 1/3, parentheses, bracket, and bracket 3 to infinity, parentheses. All right, what we have is we have two separate, distinct sets of numbers. The ones on the left and the numbers on the right. What we need to do is put those together. Mathematically, to take two sets of numbers and put them together into one, we're going to put a u between it, which is the union. What that does is it takes two sets of numbers that are not continuous and puts them together. So now this is one set of numbers instead of two distinct sets of numbers. All right, and then that gets into our lesson that's in the other video. If you have any questions, send me an email, talk to me. Do the best you can, and we'll see you in class on Wednesday.